This lesson is going to look on how we can use the discriminant and to find out unknown coefficients in a quadratic function. So for here, for example, we're asked to find q, and in the expression of x squared plus 12x plus q equals 0, and we're told that it has real roots. Okay, so since we know it has real roots, we know that the b squared minus 4ac is going to be greater than or equal to 0. Okay, because the two scenarios where the real roots is either greater than or equal to. See, so our coefficients are, this is a, b, and c here. So we have that 12 squared minus 4 times 6 times q is going to be greater than or equal to 0. Okay, so 144 minus 6 times 4 is 24. Q is equal to 0. So what's going to happen here? We can move the 144 over, so minus 24. Q is greater than or equal to 0. No, it's equal to minus 144. Okay, we're going to divide by this negative 24, so this q, and then becomes negative 144 over 24. The reason I paused there is because remember, when you divide by a negative, what's going to happen is you're going to change the sign of this inequality sign. Okay, so q is going to be less than 144 over 24 is 6. Okay, so we're saying q has to be less than 6 for this to be true. Okay, so I'm going to try and visually show you what this actually means. Okay, so here's the same quadratic from the question, where we're told that 6x squared plus 12x plus q, and we want it to be less than or equal to 0. Okay, it needs to have real roots. So at the moment, it doesn't have q is set to 6.5, but when we set it to 6, right, what happens? Well, you see here, it's touching 1 point, so now it's got this one point, so you can say that the discriminant is equal to 0. Okay, but if we decrease it even more, we now have 2 real and unequal roots. Okay, so for any value less than 6, we're going to have these real roots. Okay, because that's the only condition. But when q is bigger than 6, okay, when q is bigger than 6, you don't have any real roots. Okay, there's no real roots here because it doesn't touch the x-axis at any point. So q needs to be less than 6 for the statement in our question to be true. And I hope that's the visual representation of why this is going on. So another example of using the discriminant. Here we're asked to find p, where x squared plus p minus 4 plus a half p equals 0 has non-real roots. So when it has non-real roots, we know that the discriminant is going to be less than 0. Okay, non-real roots. So now we need to think about our coefficients and see. So our coefficients are 1, p minus 4, and a half p. So this then becomes p minus 4 all squared minus 4 times 1 over 2 p is all less than 0. Now I just need to go and solve this. P squared minus 8p plus 16 minus 2p is less than 0. So this then just becomes p squared minus 10p plus 16 is less than 0. Okay, so to know when it's going to be less than 0, sometimes it's easier to think, well, okay, if we figure out when it is 0, then we can know when it's going to be less than 0. Okay, so I'm going to change this. I'll do it in a different color just to make my point. So instead, we're going to be thinking about p squared minus 10p plus 10 plus 16 is equal to 0. Okay, well, we can just factorize this. So it's going to be like this. Okay, so it's just p and p. We want something that's going to multiply to make 16 and add up to make 10, negative 10. So 16, negative 2, negative 8. Yeah, that's it. So here -2, -8. So P equals 2 and P equals 8. Okay, but that's just answering when this equation is equal to 0. What we're actually asked is when P is less than 0. So what you want to do here is draw a sketch. Okay? Okay, and Y. Okay? So I know that P is going to be, the equation is going to be 0 there, and 0 here, or 2 and 8. Okay? So what else do I know? Well, I know it's a positive parabola, so it's going to have a minimum turning point, or a happy face. It's going to come down like this. Okay, then back up through there. So what does this mean? Okay, well, it means that for this expression to be satisfied, less than 0, well, that happens between 2 and 8, right? So then you think, okay, well, your answer just becomes when P is greater than 2, or when P is less than 8. Or you can write it out in the form when P lies between 2 and 8.